Today we're going to talk about graphing quadratic equations. If you look at the top of this worksheet, you own a company in which you sold Mr. White bobblehead toys. Right on. You're going to be rich. It cost you $10,000 to start the company. The company did well for a while, but eventually nobody wanted any more of the bobbleheads. Sad. And that's when I had my nervous breakdown. 4 years after the company began, it was worth $6,000. 9 years after the company began, it was worth $3,500. And you know that the value of the company can be modeled using a quadratic function. Do we have enough information to create a quadratic equation? What do we need to create a quadratic? We need 3 points. How many points do you need to figure out if it is quadratic? 4. You always need one more point to calculate what it is, or what kind it is, than to calculate the equation. So on my graph, I know that at year 0, I spent, well, you, not me. This isn't my company. You spent $10,000. 4 years into it, it was worth $6,000. And 9 years into it, it was worth $3,500. So if you go into the stat part of your calculator and you go into edit, you need to put those 3 points in. 0, -10, 4, 6, and 9, 3.5. Anybody need help putting those in? Once you have those entered, go back into stat and over to calc. And we want to do quadratic regression, which is number 5. And we also want to store this equation in y1. So to find y1, you go into variables. And then you go to the right column, which is y variables. And we're using regular functions. So y1 is our regular function. And this will calculate the equation and store the equation in my y equals at the same time. Yeah, that y1 will put the equation into your y equals. So if you don't want to graph it, then you don't need to do that. If all you're looking for is the equation, you don't need to put y1. Yeah. So your numbers must be wrong. -10. So what is the quadratic equation here? Y equals -0.5 x squared plus 6x minus 10. So that's the answer to the first question. What is the function for the value of the company? Okay. So the second question asks, what is the most that the company was worth? How do we figure that out? Just graph it. So push graph. You have something wrong? Oh. We did it in terms of thousands. And then you want to do, there you go. So we put ours in as -10, 6, and 3.5. You didn't store it though. So do it again and store it. Go variables, y variables, y1. Okay, everybody else okay? Everybody calculate that equation. You need some help? Okay. So my graph looks like this. Something like that. How am I going to calculate this value up here? Second calc, and go to number 4, which is maximum, and we're going to do the old left bound, right bound guess. So it looks like it's somewhere around 8, or sorry, it looks something like 6 years. So I'm going to push my left bound as 5, my right bound as 7, and my guess at 6. And it is 6, comma 8. So the question asks, what is the most that the company was worth? 8,000. And then when was the company worth the most money? 6 years. Now which one is the maximum, 6 or 8? 8 is, because that's the output. Which X gives us the maximum output? 6 does, and 8,000 is the maximum. Okay. Next question asks, what is the least that the company was worth? It depends on when the company stopped, right? Because this value over here goes on forever, so there is no minimum. No minimum. Well, negative infinity is the minimum, but we don't really care. Now, what if I push the wrong button? Instead of second calc max, I put minimum, and I said find the minimum between here and here. It's not going to give you an error. It's going to give you the lowest point between those two marks, which is like right here. So you have to be careful. If you push the wrong button, you won't get the right answer. It'll give you an answer, but the answer will be in the wrong place. Okay? So some parabolas have minimums and some have maximums. If the parabola opens down, it has a max. If the parabola opens up, then it has a minimum. And the minimums are always the y values. Always. Because if I said, what is the biggest x? Well, the x's go on forever, right? What's the smallest x? Well, they go forever in the other direction. But the y values have a highest number or a lowest number. Okay? The next question asks, when was the company worth nothing? 2 and 10. Do we trust that? I do. The next one we're not going to be able to. So do you remember how to calculate where the graph hits the x-axis? 0. So second calc number 2 says find the zeros. Left bound 1, right bound 3. My guess will be at 2. So my 0 is x equals 2. So 2 years in, you broke even. Trace is a bad idea. Because what if the answer, well, let's look. If I just do trace, I can't actually hit y equals 0, or x equals 0. So trace makes it finds points that are on the graph, but the chances of you using trace and getting the right answer, it just doesn't happen. Because it only moves 1 pixel at a time, and those pixels very rarely actually hit the x-axis. So never use trace. You'll be close, but you won't be right. Well, and you might have been lucky, but it won't always happen. All right. The next one says, what are the 3 names for x-intercepts? We call them zeros. That's one answer. The reason they're called zeros is because that's where y equals 0. They're also called roots. And the reason we call them roots will become apparent tomorrow. Have you ever planted a potato? You plant a root in the ground and the plant grows? Well, that x equals 2, is the root that will grow the quadratic. You can actually create equations if you know the roots. Okay? And the last one, sometimes we call them solutions. And they're called solutions because those are the solutions when y equals 0. All right, next story. You bungee jump off a bridge that is 150 meters above a lake, and your height above the lake in seconds can be modeled by the function f of x. So we have some kind of bridge. Beautiful. So you're standing on top of the bridge, and you're going to jump straight down. When the bungee cord is fully extended, you're going to bounce and come straight back up. So what shape is the graph going to be? If we mark it over time, am I going to be speeding up as I fall or slowing down? I'm going to slow down until I stop, and then I'm going to come back up. So the graph is going to look something like this. Now that is not my motion. My motion is straight down and straight up. But what this is saying is, at 1 second you're that high, at 2 seconds you're this high, and so on. So this is position versus time. Okay? So let's graph this. Go into your y equals, and you get x squared minus 25.5x plus 150. So I push graph, and this doesn't tell me much. What do I need to do? Which part of the window? Okay, so how high do I want to go on my y's? So I want my y max to be at least 150, so I'll put 155. That's a good idea. And I'm going to count by tens. So each little mark is going to be 10. So I push graph. Now, I also want to change my x's. So let's make our x max 20. And I can't quite see the whole graph. What else should I change? How am I going to see the bottom of that graph? Change my y minimum to like negative 20. Now when I graph it, I immediately see a problem. You're going to hit the water. Apparently you didn't learn anything in my math class and you forgot to measure the rope. So you're going to hit the water. So the first question asks, how far in the lake are you going to travel? How deep in the water are you going to go before the bungee cord yanks you back out? So let's find the minimum. So second calc minimum. And it looks like it's somewhere around, I don't know, 16. So my left bound, I'll guess 12. My right bound, I'll guess 18. And my guess, I'll guess 15. How far into the lake are you going to go? Negative 12 and a half. So that's kind of a, let me change my window. Couldn't really see that. Negative 40. Okay, I'll calculate that again. So minimum from 12 to 13 and 12.5 is my guess. So negative 12 and a half feet. So you kind of, you little underestimated the height. Yes. Yeah, that's a good point. So really, once you go down, you're going to hit the water, and especially if you belly flop, you're going to slow down a lot. So you would actually kind of look like this and then come back out. So it would come down, and then it might slow down, and then speed up again, and there's the water level. But we live in a frictionless world. So we just assume, and everything ignores friction. So this graph certainly isn't perfect, because if you only go 12 feet into the water, you're not going to be going very fast when you hit the water. So in reality, you might just hit the water and stay there for a second and then go back up. You're not going to really sink to the bottom. But whatever. We we ignore friction. But that's a good point, Micah. All right. When will you be at your lowest point? 12.75 seconds. Which one of those answers is the minimum? The y value is the minimum. That tells us how deep we are. Okay? Next question, how long does it take you to hit the water? Well, it's somewhere between 9 and 10. So second calc 0. Oops. So second calc 0. My left bound will be 9. My right bound will be 10. My guess is going to be 9.5. So after 9.2 seconds, you hit the water. When do you come out of the water again? So we're going to calculate this root over on the right. Second calc 0. It looks like it's 20, 19, 18, somewhere around 17. So 16, 18, and 17. And the answer is 16.2 seconds. So you're going to spend 7 seconds under the water. That'd be pretty terrifying, right? Especially if you belly flop, right? Yeah, and you're attached to a bungee cord. All right, now, I want to point out that this story doesn't make sense everywhere. What would this part of the graph represent? Before you jumped, right? Well, that never really happened. You were at the bridge, and then you jumped off. You didn't start above the bridge. Also, what does this part of the graph represent? You just go flying right on past the bridge, which is impossible. Okay? I mean, if you hold a bouncy ball in the air and you drop it, will it hit your hand on the way back up? No, because of friction and gravity, it's going to slow down. So when you bungee jump, when you come back up, you will never reach where you jumped off. Now, if you have a bouncy ball and you throw it down, then it can go shooting up past that. But if you just drop it, it'll never come back. Yes, unless you're wearing a jetpack. All right. Your assignment today is to graph those 6 quadratics, and you need to find either the max or the min. So if the parabola opens up, it's a minimum value. If the parabola opens down, you're trying to find a maximum value. And then you want to find the roots. And there are 3 different types of roots. You could have a graph that hits the x-axis twice. You could have a graph that hits the x-axis once. Or you can have a graph that misses entirely. So it'll either have 2 answers or 1 answer or no answers. If it doesn't hit, just write that it has no roots. Okay. Get started on that. That is due tomorrow.